Okay, so let's have a look at question 1. And this question is about aromaticity, which is and which isn't and why. Starting with the structure on the left. Now, in this case, you're told it's aromatic and asked to explain why is it aromatic. So, where do we start? Well, we need to meet the four points for aromaticity. 1, it has to be cyclic. Clearly it is. 2, it has to be planar. It is. 3, it has to be fully conjugated. Technically it is, but we need to think about that for a moment. And 4, we have to have 4n plus 2 pi electrons. So your first thought is maybe we include the carbonyl. Well, then we have 8 electrons. So we've blown 4n plus 2. Reality is more like this. Carbonyl groups are heavily polarized towards the oxygen, which means at any point I can draw a reasonable resonance structure for a carbonyl group with the oxygen taking those pi electrons, leaving us with a cation on the carbon. If I do that, then I'm at a system just like this. This is exactly what I'm looking at. If I ignore the oxygen, I just have a cation that resonates around the ring, which I can easily do. So the ring itself now, 6 pi electrons over 7 atoms, so 4n plus 2 equals 6, yes. I can involve that cation in resonance, just to show you. So it now can go around the ring, as you would expect for something that's fully aromatic. So we've got cyclic conjugation. We're good to go. So this is aromatic because the carbonyl resonance gives us a cation, which then makes it a more normal aromatic system. Second part of the question is a little different because I have a cation in exactly the same place. But the question specifies this is not aromatic. Hopefully you would have known that whether it was specified or not. And there's a couple of ways of looking at that. One, it's not fully conjugated. Well, that's true, but I would expect a little bit more in explanation terms from you at this point. Define the term. Why do you say that? A cation at that point doesn't necessarily mean conjugation or not, since we just had one that had a cation at that point that was fully conjugated. Some of you said it's just because the nitrogen's sp3, which is true. However, technically, this nitrogen on pyrrole is also sp3. Realistically, it isn't, but if we look at the freeze frame structure here, it has 3 bonds and a lone pair. That's sp3. 3 separate atoms and a lone pair. That's sp3. Yet this is aromatic. This is not. What's the difference? And the difference is a lone pair can still be a part of resonance. An atom cannot. The sp3 nitrogen in this compound has 4 atoms attached to it. There is no possibility of it participating in resonance ever. So that's the end of the story. It's not aromatic. It can't be. It's not fully conjugated because that nitrogen is incapable of participating in conjugation or participating in resonance, period. Not just because it's sp3, but because it's sp3 with 4 atoms attached. We have to be a little more specific.